All right, folks. So I want to keep this short and sweet. I want to talk about it, give you the big idea of what a z-score is, and then get to a quick example, and then you can try it on your homework. And I did make a document that has all the guided notes all in one document. I'm almost done with it, so you might need to add to it later if I make some modifications, if you make a copy of it. But you are welcome to take notes there. It's helpful to know what I'm looking for and sort of what to expect. But I'm trying to keep it short and sweet so that you don't get distracted and I don't talk about too much else. So we know what the mean is. It is the center of a data set. And typically we only use it when it's symmetric, but for calculating z-score, it's part of the formula, and so we're going to use it when we're calculating z-scores, even if it's not symmetric, although it's less meaningful in those cases. Standard deviation, do you remember? Go ahead, you can say it. Yeah, the average distance from the mean. Now, what a z-score measures is how many, the number of standard deviations that you are away from the mean, okay? And what it allows you to do is compare apples to oranges. So let's say you want to compare Tiger Woods, who's a golfer, to Michael Jordan, who's a basketball player. Well, Tiger Woods may be, in golf, it's better to be below the score. So he may be 3 standard deviations below the mean, okay? And Michael Jordan, in some statistic, whether it's value over replacement player or whatever rating you want to choose, he might have a 3.2 z-score. And so what you're measuring is compared to everyone else, okay? Here's the mean, here's how far away people are on average, and here's where Tiger Woods is relative to the population. He is 3 standard deviations away, but in the right direction, which in golf is below. Michael Jordan is 3.2 standard deviations away. And when you want to show that you're better, being farther from the mean is saying, the mean is where the normal people are. You want to be farther from the mean, okay? And so we would say that Michael Jordan, who's 3.2 standard deviations above the mean, but his statistic would be better than Tiger Woods, who is only, but still 3 standard deviations below the mean, okay, for his golf scores. So we want to measure the number of standard deviations away from the mean. So the first thing that we want to do is be how far am I from the mean? So let's make up a mean. So let's say that the mu, which is the mean of a population, let's say the mu is 50, and you got a score of, so this is on our test that we just took, okay? It was out of 52. Let's say the mean was, no, that wouldn't make sense. But let's say you got a 65, okay? So maybe it's only out of 70 or 80 or something like that, whatever. How far are you? Well, you are going to subtract and find out that you were 15 away. That's your deviation, right? But how many standard deviations is that? Was everyone on average 15 away from 50? Or is 15 far away? And so we want to count how many standard deviations. And the way we do that is we would need to know our sigma. So let's say that sigma is 7. Okay, you would be 15 divided by 7. You would be 2 1/7 of a deviation away. That would be your z-score, okay? And so that actually helps reveal what our formula is. You need to subtract how far you are from the mean and count how many standard deviations you are from the mean, and that's your z-score. So that's your formula for a z-score. You take your value, okay? So this x is a piece of data, and I keep calling it u, okay? This is a single piece of data. It's the data of interest, okay? And it's a piece of data that's from the population that has a particular mean and standard deviation, okay? We can also do it with a sample. So you could also do x minus x bar divided by the standard deviation. That's just another way to get a z-score, count how far you are away. But it's actually technically called a t-score, which we'll learn about later, okay? But your value minus the mean divided by the standard deviation. We want to find out how far you are relative to everyone else, how far you are away. and it's a z-score. So here's my example. So Eleanor scored a 680 on the math SAT, and Gerald scored a 27 on the math ACT. Who had the better score? I don't know. They both, like, 680 looks higher than 27, but they're rated on different scales and stuff. So you want to know, like, okay, what's the mean of each? Well, the mean for the SAT is 500, and the mean for the ACT is 18. So they both scored above the mean, right? This guy scored 180 over the mean. This guy scored 9 over the mean. But is 180 sounds better than 9, but they're also bigger numbers. So who had the better score? We need to calculate how many standard deviations you are above the mean. So here I would do x, right? So this is x minus mu minus 500 divided by sigma. Okay, and notice these are grouped together by that long division bar, so we end up with 180 over 100, and we get 1.8. That's my z-score. Okay. Similarly, this person, once we know their sigma, we can say, okay, well, how far apart were they from that? So we get the z is, I did that backwards. We need to take their score. The x value is 27 that Gerald scored, minus 18 divided by 6. And that gets me 9 divided by 6 is 1.5 is my z-score. Okay, so relative to their population, okay, it's harder to get, right? You're imagining, and both of these are actually relatively normal, which we'll get to later, but right, most of the people are right in here, right? And on average, people are like 1 standard deviation away. That's the average distance to the mean. Most of the people are right in there. To be 2 or 3 or 4 standard deviations is like really, 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 really hard to do, to get farther and farther and farther away from the mean. So they're both in the good direction. You want higher scores on both of these tests. This guy's farther in the good direction. And so, Eleanor, congratulations. You had the better score on the SAT. Good luck on your Z-score homework. Farewell.